Hello! In this series of video, we are going to introduce linear programming. We make a lot of decisions in our lives. Usually, we make decisions to achieve certain goals, which are also called objectives. Let me give you some examples. For example, the university bookstore needs to decide how much it should charge for a textbook. It needs to choose the price to maybe be as profitable as possible. Or maybe you're on campus today and you're about to go home, so you need to decide what is the fastest route to go home. However, the reality is we cannot simply make any decision we like. For example, the publisher may require bookstores to set the book price above a certain price point. Or, you know the fastest route to go home, but you cannot take it today because there's a construction. So, there are usually some sort of limitation on the decisions we make. If you think about these examples, they show some common features of most decision-making situations. First, there's an objective or goal that we try to either maximize or minimize. Second, there are decisions we need to make. Third, we cannot make arbitrary decisions. There are certain constraints that we need to satisfy. Linear programming, or simply LP, is a mathematical tool helping you to identify the best decisions, or we call them the optimal decisions in those situations. So again, every LP problem has these three key elements: objective, decisions, and constraints. Of course, objective, decisions, and constraints must be quantifiable. They must be something that can be presented in numbers. There are also some other requirements for LP problems. Well, first, every problem is trying to either maximize or minimize a goal called objective function. For example, maybe you're pricing a product with a goal to maximize its sales. In this case, the product sales would be your objective function. There is only one objective function for each problem. Second, the decisions do not need to be whole numbers. For example, if your decision is the price of a product, you probably can accept that your LP solution tells you to set a price at, well, for example, $10.5. But if your decision is the number of products to produce, it probably doesn't make sense if your LP problem tells you you should produce 10.5 products. Well, after all, how do I produce a half product? Let me tell you, there are ways to ask your LP problems to only give whole number solutions. But for this course, we will simply assume that every decision can accept fractional numbers for simplicity. Third, decisions must be non-negative numbers. The decisions must be either 0 or a positive number. This is really an assumption we make here. It is easy to remove this requirement, but we will keep this assumption here in this course just for simplicity. Lastly, every mathematical expression in the problem must be so-called linear. Well, you probably wonder what linear means. It's a simple concept that I will explain next. Okay, so now let's talk about what are linear functions or expressions. Well, don't be scared by the term. It actually refers to the simplest form of mathematical expression. So let's say we have two variables, x and y, okay, and we're going to use them to form an expression. Roughly speaking, the expression is linear in x and y if the variables are raised to power of 1 and the variables do not multiply each other. Okay, I know that's very dry and hard to understand. So let me give you an example. So let's take a look at those four expressions and ask ourselves, are these linear expressions? The first one, 3x plus 4y, is that a linear expression? Well, if you check out the definition over here, you will find that yes, it is. What about next one? 3x squared plus 4y. It is a linear expression? Well, no, it's not, because we have x squared here. So x is raised to a power of 2, which is more than 1. So it's not. Okay? So as long as the power here is not 1, then it's not a linear expression. Next one. 3x plus 4xy. Is it linear? No, it's not, because we have x times y. Our variables, they multiply each other. So no, it's not linear. Last one. 3 square root of x plus 4y. Is that linear? No, it's not, because here square root of x. That means x is raised to power of a half. Okay? When a variable is raised to any power that is not 1, then it's not a linear expression. So that was a very rough introduction. I'm going to present the agenda for what comes next. Okay, so in the following, we'll first talk about how to formulate a LP problem. Then we'll talk about how do we solve it. How do we solve a problem to find out the optimal decisions? Well, in here, we will talk about 2 ways to solve LP problems. First, we'll talk about how to solve a problem graphically or manually. Okay, you don't do that in practice, to be honest, but there is a purpose to do that, because that will explain to you how actually machine or algorithm works under the hood. Then we'll talk about how to solve a problem in Excel. Next, we're going to show you application of LP on different business settings. And finally, we'll talk about something called sensitivity analysis. Basically, it answers questions like, what if we change the input parameters to a model? Okay, so this is an overall roadmap for what will happen next. And I will come back to this roadmap to give you an idea where we are and why are we talking about certain topics from time to time.